In this video, we are going to focus on interconverting our different temperature units, Fahrenheit, Celsius, and Kelvin. This is part of our learning objective about converting units using dimensional analysis, but it's its own separate topic because we can't really set up conversion factors because there's equations for this that involve addition and subtraction. But we are going to be focusing on units. In order to better understand how these equations work, let's review our different temperature scales of Fahrenheit, Celsius, and Kelvin. Celsius defines the boiling point of water to be 100. So boiling point of water. And its freezing point of water is 0. The same spacing is used for Kelvin, only there's a different 0 point here. So for the freezing point of water and the boiling point of water, the difference between these two data points is 100 degrees, but they are different data points or different numerical values, but the difference between them is 100. So that means that the interconversion between Celsius and Kelvin is very straightforward. It's just the difference between where the 0 is. It's just an offset to where the 0 is. So Celsius to Kelvin, we just take our Celsius temperature and we add 273.15. It's a bit different when we're talking about Fahrenheit because the spacing between the different temperatures on Fahrenheit is different. For Fahrenheit, there's 180 degree increments between the freezing point of water and the boiling point of water, and that's different than Celsius. And so the ratio between 180 and 100 is 1.8. So 180 divided by 100 is equal to 1.8. And that's where this 1.8 comes from. That 1.8 comes from 180 divided by 100. So if you happen to remember from growing up that the freezing point of water from weather reports is 32 degrees Fahrenheit and that water boils at 212, you can always subtract 212 minus 32 to get 180 and then know that the difference for Celsius is 100. And then you can kind of derive the equation if you ever forget it. This minus 32 and plus 32 is to adjust where the 0 point is for the freezing point of water. Because obviously if you're at 0, then you're going to need to bump it up to 32. Because 1.8 times 0 is 0. So you're going to have to bump it up to 32. All right. So here's an example. It says a hot summer day in Fresno is 113.0 degrees Fahrenheit. What is the temperature in Kelvin? Now, if we go back to this slide, we can see that in these equations that are provided on your yellow sheet, there isn't a direct path from Fahrenheit into Kelvin. So we're going to have to go into Celsius first. And so I'm going to need both this equation and that equation in order to go from Fahrenheit to Celsius to Kelvin. So my degrees Celsius is equal to whatever my degrees Fahrenheit is minus 32 divided by 1.8. And so I have to treat the 32 and the 1.8 as exact numbers when I do this. And so that's 113.0 degrees Fahrenheit minus 32 divided by 1.8. 113 minus 32 is 81. This is significant to the tenths place. And this didn't have a tenths place according to my calculator. But I follow significant figure rules, so I have to make sure that I follow significant figure rules. And so we will now divide that by 1.8. And so now my degrees Celsius is equal to 45.0 degrees Celsius, because now I switch to my multiplication and division rule. This 1.8 has infinity, just like this had infinity decimal points. And so now I have 1, 2, 3 sig figs in the numerator. 3 sig figs is less than infinity, so that's 45.0. So a hot summer day in Fresno is 45.0 degrees Celsius. But that wasn't the end of the question, was it? It was about Kelvin. Got to get to Kelvin. So to get to Kelvin, we have to add 273.15 Kelvin. And so that is plus 273.15. And so that's 318.15 Kelvin. And so that's 10th place. And so this is significant to the 10th place. This has infinity decimal points. And so 10th place, 318.2 Kelvin. Okay. Here's a practice problem for you. It says one day in December in Australia, the temperature is 31.8 degrees Celsius. The U.S. typically reports the weather in Fahrenheit. What temperature is this in Fahrenheit? Go ahead and pause the video and try to work this out. Unpause the video when you are ready. Okay, let's go over this. Before we get started calculating, let's make sure that we make a prediction that's somewhat accurate. Australia is in the southern hemisphere. That's important because in the southern hemisphere in December, it is summer. So I hope that this temperature is warm. So let's go ahead and do our math. So to get our degrees Fahrenheit, we are going to take 1.8 times our Celsius temperature, and then we are going to add 32. And so we'll take our degrees Fahrenheit, do 1.8 times 31.8, and then we will add 32. And so 1.8 times 31.8 is 57.24. This has 3 sig figs, so 1, 2, 3 sig figs there, and then I'll have to add 32. And so this 2, the third sig fig, ended up in the 10th place, and this is infinity sig figs. And so once I add the 32 to that, I end up with 89.24, and this has to be rounded to the 10th place. And so I will report my answer is 89.2 degrees Fahrenheit. I'll round down because 4 is less than 5. This is warm, and so it matches our prediction of it being summer. All right. In summary, I hope that you have learned in Module 3 that measured values have some degree of uncertainty. You should always write your units, and when you record measurements, you should have just one estimated digit that reflects the precision of the instrumentation used. Significant figure rules should be followed throughout all calculations, and you should put units on everything. We use SI units, and the most of the planet uses SI units. We should all use SI units because they're better. And dimensional analysis is a very powerful strategy to help us solve problems because units are so important. Units are units, and units are everything. If you look at the units and focus on the units, you can learn to survive chemistry and physics. The end.